So, Assalamualaikum, Namaste, Wanakkam, my dear students. So, how are you guys? My future doctors and audience. So, you miss me? Yes, of course, I know. So, we are came with a new section, new part of the physics. So, we are getting our mains soon here. So, we must focus on the important topics. So, we are focusing on thermal physics. We are starting a new segment, thermal physics. Say mechanics, electronics. Like this only, thermal physics is one part of the physics from which you will get more questions. I'll say thermal physics consists of three topics. One, heat and thermal expansion. Next, thermodynamics. After that, kinetic theory of gases. Okay, now let us get started with our main topic, heat and thermal expansion. Now, what is this heat and what is this thermal expansion? Okay, first of all, a general introduction. In this chapter, we are going to study about measurements of temperature. First of all, we will study in this chapter measurement of temperatures. And one more thing we will study in this chapter. See, when temperature changes now, temperature changes from cold to hot, that time what are the effects we can see? What are the effects we can see that we will study? Well, then we will study effects take places in body due to changes in temperature. Again, this we are going to study in this chapter. Now, basically, measurement of temperature. To measure the temperature, we produce some instruments like thermometer, etc., etc. That we will study. Okay. Now, let's get started without wasting our time. Now, first of all, one major thing. How we know that there is temperature or there is heat, and what is this main temperature or heat? See, I will give you one small thing. What is heat or what is temperature? Now, till this you have studied three physical quantities. One, length, mass, and one more time. Now here, heat is also a physical quantity. No, heat is not a physical quantity. It is a fundamental physical quantity of temperature. So now you are studying one more fundamental physical quantity. Fundamental physical quantity. Till now you studied length, mass, and time you studied. Now we are adding one more to this, which is temperature. Temperature. Now let's get started. Temperature. First part of this temperature is heat and temperature. Okay, we got it. Sir, we are going to study this part. Okay, sir, fourth fundamental quantity, temperature. Now, what is this temperature and what is this heat, sir? Sir, I am studying from LKG, UKG. Sorry. I am studying from 7th class, sir. But I didn't understand what is the difference between heat and temperature. Both are same. Both are different. So let's get started. See, if I take a small, okay, now we are going to learn about difference between temperature and heat. Okay, now temperature and heat is both are not same. These both are different from each other. Now let's get know what is the difference. Now, see, if I take one small container, it is big. Okay, if I take one container like this, value is fixed. If I fix the value is fixed. It is not velocity. V is velocity in kinematics, but here V is volume. Remember this, V is volume. If I take this small, now you know one thing, if I take inside this gas, if I take inside the gas, it will have gas molecules like this, every, correct? Gas molecules, gasolina, gasolina. What is that song? Gasolina, which movie? iMovie, yeah? I don't know. Oh, fine. Whatever the movie. Now, these are the gas molecules, correct? These are the gas molecules. You know one thing, we know one thing. Gas molecules are randomly moving. Correct? It don't has a shape, it don't has a value, so it will move random. It will collide with the walls, it will collide with each other, blah blah, some theories we will study afterwards. Now come to main topic. Now this gas molecules, it is fixed, value is fixed. Inside this I feel like gas. I feel like gas. Okay, now somehow I am keeping here a small heater. I am heating this. No, don't take I am heating this. Okay, I am heating only, but you take I am giving some external energy. Okay, once I give some external energy, what happens? These molecules, if I take here, these molecules will start moving randomly. These molecules move from here. See, basically inside gas, molecules are moving. It is not stopping. It is not stationary at one point. It is like moving. These gas molecules is like girls' mind, always mood swings. Like this. Okay, now, so here gas molecules are moving. Okay, now when I apply some heat, it moves very fast. If I apply some external energy, it moves very fast. This movement of gas is there now. This movement of gas molecule. If something is moving, we call it as kinetic energy, right? Now, this movement of gas molecules or the kinetic energy of these gas molecules is called as temperature. This kinetic energy of gas molecules is called as temperature. So, you can say temperature is form of energy, or you can say kinetic energy of gas molecules. Kinetic energy of gas molecules. Now if it is moving like this, you know one thing, it is moving, it will collide with the walls. So that moving molecules is called as temperature. So, sir, then how we say temperature is increasing or temperature is decreasing? Array, very simple. See, very simple. If I take one small, you know one thing, this PV is equals to nRT, you know. Correct? Okay, I will write here clearly. Fast. When we are in flow, no one is going to stop us. Correct. See, we know one thing, PV is equals to nRT. Now, you know this is constant. Leave it. Now, here I am fixing volume also constant. Correct. If I fix the volume, then if I give some external heat, which means if I increase the pressure, my temperature is also increase. And here, if I increase the kinetic energy, see, if I increase the kinetic energy, then also my temperature will increase. See, afterwards you will get one formula which relates energy as this. This we will study afterwards. Okay, now, so energy increases, temperature increases. If temperature is, say, if energy is increasing, which means movement of molecules is like this, like a magnetism. So if energy increasing, kinetic energy is increasing. If kinetic energy is increasing, temperature is increasing. This is called temperature. Now, next term, which is heat. Next term, which is heat. Let's get started with our heat. Heat. Okay. Well, now heat. Sir, what temperature is a temperature? Clear cut we understood, sir. Now heat. See, if this body has some temperature, okay, has some more temperature. Let's say this body has a temperature of 100 Kelvin. Now what I do, I will bring one more small body to attach this. One body has temperature 100 Kelvin. Now I bring one more body which has temperature, let's say 10 Kelvin. If I make them attach together or stay together, or it is like you got fever, your mother touching this, your neck. Then what happens? Your mother feels some heat of your body, right? Similarly, if I keep this touching for 1 second, they will just feel the heat. Okay? If I keep this attached for more time, then this 100 Kelvin, it will share to this. If I keep this more time, then this 100 Kelvin and this will share, and we will get one equilibrium. We will get one equilibrium stage at which we will have this temperature as 55 Kelvin and this temperature as 55 Kelvin. Now, this temperature is shared, right? This temperature is transfer. Temperature transfer means energy is transfer. Energy is transfer. This energy transfer is only heat. Energy transfer is only heat. See, temperature means movement of molecules, kinetic energy. Now this flow of kinetic energy from one body to other body is called as heat. So heat is heat is flow of energy or sharing of energy. Sharing of energy. Okay, now see, temperature transfer from one body to other body in the form of heat. Temperature transfer from one body to other body in the form of heat. Okay, now so sir, for example, okay, see, if you get fever, best example, if you get fever, our parents will say, don't sleep with him. If I got fever, my mom will say to my brother, don't sleep with him. Why? Because if he sleep with me, he will also get fever. Correct? This flow of temperature, my body is already cold or hot, and this condition will go to my brother. That flow is there, now that is only called heat. Okay, now clear? Fine. Now. What is? Okay, take note first. Temperature is a form of energy. Temperature is a form of energy. Temperature is a form of energy. Heat is a flow of energy. Heat is flow of energy. Basic information. Now, how we know that any body has temperature or not? See, how we know any body is having temperature or not? See, basically, this temperature of body is depend on, see, this temperature or heat is depend on coldness or hotness of any body or object. Any body or object. See, if I want to, I'll just take you to one example. If my body, say, if I take my body, which has, let's say, temperature 27 degrees Celsius. Okay. Now, one more person who got fever, he has temperature, let's say, 100 degrees Celsius. Now, how I will get to know that he has fever? My body is normal. My body is normal condition. My body is normal condition. No more heat. If I touch him, his body has more temperature, more heat. If I touch him, what will happen? My body temperature is low. He is high. So my body, which is low temperature, when I touch this, some temperature flow from that body to this body, and I will feel like his body has more temperature. I will say he has fever. Okay, now, so temperature or heat is depend on coolness or hotness of any body or object. It is depend on how one body is cool or one body is hot. One body is cool or one body is hot compared to other body. Compared to other body. Compared to another body. Fine. Super cool. Okay, super cool. Now, to measure these temperatures, how to measure this temperature? How we know that any body has high temperature or any body has low temperature? How to measure this? How we know that one body has high temperature or one body has low temperature? So, how to know? How to know? For this, what we do now? We take some instrument, we take some instruments which changes according to heat or cold of object or body. And what we do, how to know heat or temperature of one body? See, if I want to know the temperature of one body or heat of one body, what I will do? I will make one instrument which shows the difference in temperature. Now for that what I will use, I will just use only small instrument which nowadays we call as thermometer. At that time we used to build it like this, a small longitudinal pipe with a small circular. Okay. Now this I will fill with the mercury. This I will fill with mercury or alcohol. Mercury or alcohol. Now, if I fill this with mercury or alcohol, once if I pass this some heat, then this body, see, if I take this as something A, if I heat this, then value is fixed now. So because of this heat external energy, this rises to this. It will come to here. It will come to point B. Then I will say there is rise in temperature. See, I know if I heat any alcohol which is liquid, mercury, if I heat any liquid, you know one thing, if I heat liquid, it will become vapor. Correct? It will become vapor. Which means if I heating liquid, the molecules will move very fast, right? If it is moving very fast, temperature increases, correct? So similarly, if I heat this alcohol or mercury, it will start increasing. Molecules move very fast. Then point A will increase to point B. This way, I can say that there is increase in temperature. This is what we are using in our modern thermometers. Now, there is one more device which is called as pressure gauge. See, pressure gauge or manometer. Now, this is very interesting. This is very interesting device. It will have like this. Okay, now it will have like this. Now, if we will fill this with gas or any liquid, okay, now, if I fill this with gas or liquid, if I pass this here some external energy, then what happens? Molecules move very fast. These molecules moving very fast will expand here to here. These molecules will move here and it will make this needle which is here to move like this. This needle will move here like this. As amount of needle move, that amount of temperature is there. The amount of needle move, that amount of temperature is there. This is called as Gauge pressure gauge. This is how we say there is temperature or there is increase in temperature or there is, now if I cool this, then it will show deflection in another way. It will show deflection like this. It will show deflection like this. We can say temperature is decreased. If it is here, if I cool this, then temperature will decrease. See how this liquid which has some molecules moving. If I cool this liquid forms to ice, which means molecules are not moving. So it will decrease. Temperature is decreased. This is how we say. There is one more method. We can say that. One more is resistance of wire. Resistance of wire. Now it is interesting. It is very interesting because when I was in 7th, I did one experiment in exhibition based on this. That is other part that I didn't get any prize, but I understand the concept. Why? Okay, 7th I did this. I am probably saying in 7th only I did this, which is in 11th. Now what is this now? See, if we have two poles, you see in poles in our society, we have two poles which has lights, correct? Lights. Now, you know there is one connection here like this wire, 3 wires, correct? There is 3 wires like this. Now, if you take two conditions, summer and winter, you know one thing, winter is cold, summer is very hot. Now, at the summer time, this wire will become like this, hanging. And in winter, it will become like this. Normal. In winter, it will be normal. Normal. Why? See, because temperature, it is normal. It is summer, which is hot. Which is hot means the molecules or particles in the wire which started moving fast. If it is moving, temperature increase, which causes heat, so it will become like this. Okay, now this is the reason why when we construct bridges or when we construct railway track, we will just leave a small place, this much place, between two tracks, between two bridges like this attached, small place. Because in hot, it will expand. Expanding means temperature is increasing. That is why we built like this. Okay, now fine, cool, good. Take down this first. Then we will see one more thing. Okay, fine. Divine. Nature is divine. Which wine? Divine. Sorry, not nature. Education is divine. Education is divine. Wine. Array, I won't drink any wine. I am very teetotal. Fine. Now, next one is thermal partition. So, next one is thermal partition. Thermal partition. Now, 1 minute, please. अरे पार्टीशन हो गया वो सॉरी यार पार्टीशन फाइन thermal partition हो गया ना fine adjust. Now what is this thermal partition? Now thermal partition, it is very basically one simple thing here. No need to stress your mind. Very basic things. Now see, if I take one small box A and one more small box B. Okay. Now if I attach here like this temperature and here like this temperature. Let's say this body has temperature T1, this body has temperature T2. Then this will become, this thermometer will also get that same temperature. Let's say this has more temperature. If it is having more temperature, then this thermometer will become temperature T1 and this thermometer will become temperature T2. Correct? Temperature here is more. For example, here it is more, here it is less, let us say. Here it is less. Okay, first case. Now what I will do, I will just make them attached together. It is different body, What I will do, I will just, what I am doing, I am just attaching together. I am not doing anything. Okay. If I attach together, if I attach body A, body B, now main thing, which has temperature T1, T2 now, if I attach this body both, then we will get a beautiful phenomena. We'll get a beautiful phenomena, which is like this. Oh, sorry, yaar. I had more pedrost. So, it's coming. So, which is like this, temperature of these two bodies will become same. Which tells temperature of this will be same. Temperature of this will be same. Temperature of both will be same. What an interesting, right? Sir, what is interesting? Just temperature is transferring, that's all. Yes. Yes. Now there is one more case. This is simple, we know. Now come to main part. If I take same bodies, body A, body B, attach with some insulating wall. Then whatever the temperature here, it will be same. See here T1, right? T1, T2, T1, T2. Now why this? Interesting. Why? 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 See, when I attach both, temperature changes and become equilibrium. Here, when I keep an insulating wall, insulating wall, then it is not, temperature is not transferring. It is same as T1, it is same as T2. Why? What is this both cases? What is the difference in between these both cases? One thing is different. Yes, you are correct. Here there is no wall. Here there is a wall. Then what this wall is called as? This wall, it is called as, this wall, where can I write? This wall, it is called as sorry, 1 second. Adiabatic wall or adiabatic suppression. This wall is called adiabatic wall. Adiabatic wall. This wall is called as adiabatic wall, and this wall is called as diathermic wall or diathermic suppression. Adiabatic wall. Adiabatic wall. Okay, now fine. Now, this is the main thing. Okay, take down first. See, this we can write even it as adiabatic wall. Okay, now fine. Don't take anything. Both are. It's okay, fine. Okay, fine. Over. Arey. Sir, why you are teaching this much slowly, sir? I am not teaching slowly. I am just like building your basics. Once your foundation is strong, then you can easily make some rocking things. Like our rocking star, yes. Fine. Finest. Now, next topic is temperature and states of matter. Temperature and states of matter. Temperature and states of matter. See, this I don't need to tell you, but also I will tell you. This I don't need to tell you, but also I will tell you. What did I like? What of you? Now, you know one thing, states of matter, you know. What is the states of matter? One, you know, which is solid. One more, you know, which is liquid. And one more, you know, which is gases. Correct? Now, the major thing is, let us come from gases. Now, gases, it has 9 number of molecules. Molecules are moving random. Correct? This I won't read. Molecules are moving random, which means separation between two molecules is more compared to size. Correct? One thing, separation between molecules is more. Correct? This separation is more, which means it will move very fast. If it will move very fast, separation is more. Okay? And it don't has a perfect value. No value. I'll just say no value. No shape. No shape. No shape. Now this is gases. Sir, why we are studying? I will tell you why we are studying. Just relax. Now, if we come to liquid, the separation between two molecules is comparably okay. Less than this, it is comparable to this diameter of that molecule. Separation between two molecules of liquid is comparable to diameter of molecule, which means separation can be okay, measurable. I can write measurable separation. Measurable separation. Okay. then it has no shape, but it has volume. It is volume, correct? Now if I come to this separation between molecules is very less, which means molecules are tightly packed. Molecules are tightly packed. Molecules are tightly packed and has volume and shape. Major. Okay. Sir, why we are saying? I will tell you, relax man, relax. To go from here to here, we need to rise more temperature. To come from here to here, we need to cool more. That is very actually. Okay, now this is a basic thing, important thing about states of matter. Fine. States of matter. Now after this, to measure the temperature of body, we use some device which is called as thermometer to measure the temperature of body or object. We use instrument which is called thermometer. Okay, now we use device which is called as thermometer. Now there is thermometer. Here comes the main part of our lecture. Here comes the main part of our lecture. This thermometer, now we can have three values. We can have three scales of thermometer. We can have three scales of thermometer. Here is the main part of this lecture. We can have three scales of this thermometer. One scale which is Celsius scale, and one more Kelvin scale, and one more Fahrenheit scale. Fahrenheit scale. These are the three scales of temperature measuring. Okay, now let's get started seeing one by one temperature measuring scales. Okay, fine. Take down first. Okay, fine. Okay. Now, next part is very, very good. Very. Okay, next segment, which is very important segment. From here we have seen in NEET, we have seen in IIT mains questions. Now what is that segment? Now it is thermometer. Now basically thermometer means what? See, thermometer means not only the pipe which you keep here. No, thermometer means any instrument which shows changes according to rise in temperature or cool. Thermometer is an instrument which changes according to change in temperature. Okay, now thermometer is an instrument which changes values according to changes in hotness or coldness, you can say, or temperature. Fine, temperature. Or you can say any instrument which shows changes according to changes of temperature is called as thermometer. See, this is very good definition. This is very better than this. Any device which shows us changes according to change in temperature is called as thermometer. Okay, I said just now thermometer has one value scales, Celsius scale and Fahrenheit scale and Kelvin scale. Now let's get started with the Celsius scale. Celsius scale. See, Celsius scale, we have here one beautiful thing. In Celsius scale, we take two important points, which is like ice point and one more is stream point. One is ice point, one more is stream point. Now, what is this ice point and stream point? Now, any scale has lowest value, has highest value. Any scale has lowest value, has highest value. Now, ice point is the lowest value of Celsius scale. Ice scale is the lowest, ice point is the lowest value of Celsius scale. And its value is, we have given 0. And steam point is the highest value of Celsius scale, which we have given as 100. Sir, got it, 0, 100. What does this mean, ice point? And what does this mean, steam point? See, ice point, it is an equilibrium point between mixture of liquid and ice at 1 atmospheric pressure. 1 atmospheric pressure. 1 atmospheric pressure. Which means 1 atmospheric pressure, or atmospheric pressure means the pressure at the sea level. So when you take the sea level, at the sea level, in the mixture of liquid and ice has this point, ice point we call. Okay, now steam point means same. Steam point means same. Equilibrium point between mixture of liquid and solid at 1 atmospheric pressure. This is ice point and stream point. See, you just remember, ice point is the lowest value, stream point is the highest value. Okay, ice point is the lowest value, stream point is the highest value. Fine. Now, after that, see, there is no fundamental rule to take ice point as 0 and stream point as 100. See, I will write for you. There is no fundamental rule. There is no fundamental rule. For you, I will write. See, there is no fundamental rule to take ice and steam point as 0, 100. Streamer. Steamer. Sorry, it is steam. S-T-E-A-M. Steam. Steam point as 0 and 100. There is no fundamental. In any question, I can take steam point as 30 and ice point as 30 and stream point as 300 also. 300 also. You must get ready. Okay, now you just know one point, stream point, lowest point, stream point, highest point, ice point, lowest point. This is the main thing. There is no fundamental 0 to 100. Okay, now fine. Okay, fine. Now this Celsius scale is also called as centigrade state. Okay, now this Celsius scale is also called as centigrade state. Centigrade state. Okay. Okay. Now let us get into one more simple topic. How to measure temperature. See, I will tell you one thing. If I take glass thermometer, say in thermometer there are many types, but popular thermometer is glass thermometer. Popular, you can say popular is glass thermometer. Now, how to measure temperature? Let's see. How to measure temperature now? Here is your, let's say, one thermometer which has length, let's say L0, which has length L0. Now, because of this heat, this body has this much. Okay, one more line, right? This body got this much liquid or mercury. Say thermometer, you know, right? In doctors, they will keep the body, it's a mercury rise from here to here. Okay, now let us take this point as L. Now, if I take these 2 points, then what is a temperature? I can say temperature as L minus L naught into 100. This is the formula to find the temperature. This is the formula to find the temperature of any body. Now, if I take one example, I will tell you one instrument has 100 readings. See, for example, one instrument has 100 degrees Celsius, and the temperature, say, the value of this rises to 120 degrees Celsius. 20 degrees Celsius. Then what is the temperature? Means you will substitute this here, you will substitute this here. Sorry, one thing, there is a small mistake. Now, if I just take one body, one thermometer has 100 divisions. Now this mercury rises to 20 divisions. Now, then what is the temperature? Means you will write T is equals to 20 divided by 100 into 100, which means your temperature will be 20 degrees Celsius. Okay, now fine. More full value divided by low value. Now we can ask questions like one body, one thermometer has 50 division and rise to 20. It has, let's say, it has 50 division. It has 50 division, rises to 20. Then what happens here? It will become 50. If it is 50, then I know one thing. This cancels. 5 1s are 5 2s are. Then 40 degrees Celsius. Be prepared for all this. Okay, fine. Super. This is very, very important. Mark it like this. Star in your book. Fine. Okay, good. Take down fast. Okay, fine. Over. Okay. Now, to any body, to measure temperature, we have one certain rule. Which one certain formula? To measure change in temperature or temperature, we have one rule or one formula, you can say. That formula is like this. X minus, you can say, ice point divided by steam point minus ice point. This is fundamental formula. This is fundamental formula. Now, if I write this formula for Celsius and Fahrenheit and Kelvin scale, how it will be? See, if I write for Celsius scale, before writing for Celsius scale, I will tell you one simple, okay. Now, Celsius scale, T Celsius minus lowest value of Celsius scale is 0 divided by highest point of Celsius scale is 100 minus lowest point is 0. So overall, Celsius scale TC divided by 100. Okay, fine. Now, if I write this in form of Kelvin scale, Kelvin scale, I need to tell you one thing before writing in this. Now here, 0 Celsius, Kelvin takes as 273 Kelvin. In Kelvin scale, 0 value is equal to 270 Kelvin. 0 degrees Celsius is equal to this much. 0 degrees Celsius is equal to this much. Okay, now fine. Now, if I write in this form, I know T Kelvin minus lowest point, which is 0, which is equals to 273, and highest point will be 373 minus 273. Highest point in Kelvin scale is 373. Or in some books they are given 373.15 minus 273.15. It's okay. Both are same. No need to worry about this. Now it turns out that my Kelvin scale value will be T of E minus 273 divided by 100, which is equals to this same. Both are equal. Both are equal. You can write this formula as this. After writing this is equals to constant value. Okay. Now this is okay. Fine. Super. Now if I want to write in Fahrenheit, okay, take down this first. Then I will write in Fahrenheit. Fine. Okay. Over. Thank you. If I want to write in Fahrenheit scale, here Fahrenheit scale 0 degrees Celsius turns to 32 degree. And my highest value, which is 100 degrees Celsius, will turn to 212 degrees Celsius. 32 degrees. And the difference between these two is 180 degrees. Now if I write this in form of this, see, Fahrenheit minus 32 divided by, I can say 212 minus 32, which is equals to T of F minus 32 divided by 180. This is the formula to find Fahrenheit heat. This is equals to this, which is equals to Kelvin minus 100, Kelvin minus 273, right? Kelvin minus 273 divided by 100. These three are linked. This is how these three are linked. From this is how we can convert to Fahrenheit to Celsius, Celsius to Kelvin, Kelvin to Fahrenheit. Easy thing, right? Very easy thing. Take down first. Such an easy thing. Okay, fine. Okay. What I said? Three. See, per end point. Now, this ice point is also given as lower end point or upper end point. Or lower field point or upper field point. See, lower field point in some books they have mentioned, upper field point, lower field point. In some book they have mentioned steam point and ice point. Whatever you can take, but concept is very important. Now this is equals to Celsius scale, which is T Celsius is equals to 100, which is in Kelvin scale T Kelvin minus 273 divided by 100. In Fahrenheit scale, T Fahrenheit minus 32 divided by 180. Okay, now all are equal. If I want to write change in temperature, see, change in unknown temperature divided by upper value minus lower value is equals to change in Celsius scale by 100 is equals to change in Kelvin scale divided by 100 is equals to change in Fahrenheit scale divided by 180. 180. Now, if I compare any to this scale, see, if I compare this, can I write change in... Hey, what I did? Sorry, one small mistake. Alright, fine. Now, see, here, if I want to write, I can write this as like this, see. Super cool. Correct. So this is how we will change from one scale to other scale. Okay, take down first. Good. Fine. Now. There is one simple things to say. There is one last theory to say. See, there is never ever. There is never ever. Right. See, when body is rising temperature, there is no end point for rise of temperature. You can say there is no end point to rise in temperature. Okay, fine. There is no end point to try. There is no limit. But to cool temperature, there is limit. Okay, now till before, you know one thing, 10 to the power of 10 years ago universe was born. Correct? We say one thing. One second, please. Say 10 to the power of 10 years ago, universe was born, right? Universe created. Now, at that time, we got world's highest temperature. See, that time we got world's highest temperature, and that is 10 to the power of 39 degrees Celsius. That is 10 to the power of 39 degrees Celsius. Now, and this is what we have measured highest, and what humans created highest value of temperature. What humans created, not this is natural. Humans created highest value of temperature is 10 to the power of 8 degrees Celsius at nuclear exposure. Okay, and the lowest value what humans measured is 10 to the power of minus 10 degrees Celsius in nuclear cooler spin. Okay, in 1992 something. In 1992. Till now humans measured, this is the highest degree temperature what we got in nuclear explosion. And this is the lowest temperature what we got in cooler. Okay, now, and one more thing, there is no negative Kelvin scale. You know this? There is no negative Kelvin scale. Okay, one thing, wait 1 second. Okay, fine, take down first. Oh, okay. I got it. This comes in Kelvin, not in Celsius. This is what I was saying. This comes in Kelvin. Sorry for the inconvenience. This comes in Kelvin. Okay, this comes in Kelvin. Kelvin में आएगा, Celsius में नहीं आएगा. So Kelvin. If you want to convert to Celsius, 273. You know one thing, 273. So Kelvin. Fine. Take down. Okay. Now let us jump to our problems. One thing, please, 1 second. I will just start our problems. Okay, where is the duster? Where is the duster? See, I won't write any question, but I will explain you every question. I won't write any question, I will explain you every question. Now, question is like this. Temperature of patient, write down, temperature of patient is 40 degrees Celsius. Find the temperature on Fahrenheit scale. See, temperature of one patient is 40 degrees Celsius. Now, this temperature, they are saying to find in Fahrenheit scale. They are saying they have one temperature of 40 degrees Celsius. They are saying to convert this 40 degrees Celsius to Fahrenheit. Now, how to convert this Celsius to Fahrenheit? You know one thing. You know degree Celsius minus 0 is equals to 100 is equals to 0 into degree Fahrenheit minus 32 divided by 212 minus 32, which is turns to TC by 100 is equals to minus 32 divided by 180. Correct. Now they are given this value, so we need to substitute here. Then 100 is equals to T of F minus 32 into 180. Now 0, 0 here, 0, 0 here get cancelled. Then I will remain with 40. 4 into T of F minus 32 into 18 here. Now if I do some subtraction, then 18 into 4 is equals to T of F minus 32. Now if I want 32, what I will do? 18 4s are how much? How much 18 4s are? 32, 36, 32, 72 plus 32 will come, which turns like to 104 degree Fahrenheit. 104 degree Fahrenheit. Take on first place. Take on first place. Okay, this is one simple problem. This is one simple problem. Now let us see one more problem. Problem I will write. Please take on the problem. See, at what temperature is the Fahrenheit scale? At what temperature is the Fahrenheit scale reading equal to the twice of Celsius scale? At what temperature Fahrenheit scale reading equal to twice of temperature of Celsius scale? Which means I need to give this what temperature so that it is equal to twice of this temperature. Which means can I take it as T of C is equals to, let us say, X temperature, any X temperature. If in Celsius scale, if it is C, they are saying, okay, I will write the question. Very simple. Now if I take Fahrenheit scale reading as T of C, then T of F I will be taking as 2x, correct, of temperature 2x. Now if I substitute this, x by 100 is equals to 2 of x minus 32 Fahrenheit divided by 180 degree, 0, 0 cancels, we know this. Then if I do simple, then what happens? Here 5, here 9 will come. Then 9x is equals to 10x minus of 32 into 5, 10, 3 5s are 15, 16, 160, correct, 160. Then I will get value as like this, like what, 160 is equals to x. Okay, now 160 is equals to x, correct, 100% correct. Okay, take down first. Okay, good. Now take one more question, please. Take down the question. See, question is like this. The lower and upper fixed point of a faulty thermometer is 5W and 105W. They are giving lower point which is equals to 5W and upper point is equals to 105W. Okay, now if the thermometer reading is 25W, what is the actual temperature in Celsius scale? Now if thermometer reading is 25W, then what is reading in Celsius scale? That's all. See, what they are giving is, they are given one temperature, one thermometer whose lowest point is 5W, highest point is 105W. Now this temperature here is 25W. Now what is the temperature in Celsius scale, they are asking. Very simple. For this you have two methods. Let us carry on with one method, first method, which you know one thing, that x lowest value. Okay, I will write this ice point. Ice point divided by, okay, x minus ice point divided by stream point minus ice point, which is equal to Celsius scale, which is tempering Celsius, minus 0 is equals to 100, minus 0. One method to do. Now here they are given x value which is 25, and lowest point value which is 5, and highest point value which is 105, and lowest point value which is 5 is equals to T of C by 100. Now if I do this subtraction, then I will get 20 by 100 is equals to T of C by 100. Now 100 get cancelled. T of C is equals to 20 degrees Celsius. I got answer. 20 degrees Celsius. I got answer. Very simple. Very simple. Basic method to compare. Okay. Now take down first. One more method I will tell you. Okay. Now one more method is this. I have told you to find the temperature, which is like to find the temperature. I know L minus L naught into 100. Correct? This full length is L naught. This length is L. If I substitute here, now my L value is, which is 20. L value is 20 because it is reading from 5. Divisions are 100. Reading from 5, which is 20. Divided by over division is 100. Number of division is 100 into 100. So 100 cancel. I get 20 degrees Celsius. Which method you want to use, it depends on you, but use any method. Okay, fine. Take note. Okay, I think class is getting more. Okay, we'll meet you in next class. Now, till then, we have given our DPP. We have sent DPP in WhatsApp community and even in our Telegram. So your point is to see the class full and follow this method and solve the DPP question, which has nearly 7 to 8 questions based on all this topic. Cover this topic today only. Complete this. Then be happy, be strong. Now we will meet you in next class. Till that, bye bye.